Okay, here we have what was sign. Alright, video 3-1. Sorry. Okay, two long straight parallel wires carry currents that are directed perpendicular to the page as shown in the figure. Wire 1 carries the current I1 into the page and passes through the x-axis at x equals positive A. Wire 2 passes through the x-axis at x equals negative 2A and carries an unknown current I2. The total magnetic field at the origin due to the current carrying wire is the magnitude 2 pi I1 divided by 2 pi A. The current I2 can either have two possible values. Okay, so in this scenario, we can either have both wires carrying current in the same direction or carrying current in the opposite direction. If they're going in opposite directions, their magnitudes will be lower. Does that make sense? The current will have a lower value. But if they're going in the same direction, okay, let me just draw it. It just would make more sense. I'll draw like each scenario. So this is our unknown one. It's probably not as straight, but whatever. And this is our known one. We know this is I1. Okay, we don't know I2. We don't know what I2 could be. Now, the first scenario is that they both go in this direction. And that would look like one. And then I drew B1 a little larger than I wanted to, but B2. Okay. Because we know that currents in the same direction repel each other. No, currents in the same direction attract each other. Currents in the opposite direction repel each other. Okay. And this would be our other case. This is our known I1 again. But this time I2 could be in the negative direction. Now this diagram will look something like this. Just make sure I draw this right. 1 and 2. Alright, and the fields on these wires when they both go into the page, and this is our like point in the middle, we force this way, and then we force this way. But when one's in and one's out, that's our middle color, whatever. One in and one out, they'll both go in the same direction. Right? So when the currents are going in opposite directions, the force will act in the same way, meaning each force, I don't want to say each, but like the individual forces from each individual wire will be less in order to add to this value. But when they're going in the same direction, as you see, they're like fighting against each other. So one of them must be larger than the other to, win the force. I feel like that makes sense. Okay, so now we actually have to solve our stuff. So this is basically like part A now. So our total field, if you will, these clashing fields. Yeah, okay, you know what I mean. Our field will be equal to B2 minus B1. And then this can also, we know we have a value for B1. We have a value for our total, I just want to make sure I'm using the right word. Our total field, and we have a value for B1, and that the currents attached to them are both I1. Now for B2, the current attached is I2, so we're going to solve for I2, so we're going to have B2 is equal to I guess summation of B plus B1. Okay. And then here we're just going to use our I don't know. You know what I mean? This is our formula for the value field. For each individual one, I should clarify. And then again, like I said, these both, on this right side here, both have I1 as their value, meaning we can combine them. And then they all have the same denominator, so that cancels, except watch out for this 2. That could be an easy mistake. You cross out that 2, and then you're off by a multiple of 2. And then also our, oh shit, I don't remember what that symbol's called. Wow. 2 over 2 is equal to 2. And again, then the 2 in this numerator, so we actually have 3I1. And I2 is equal to 6I. And then it's part A. But that's assuming this. Where's it? Let's see if I can figure out where I drew it. That setup was assuming this setup. As I said, we were expecting a pretty large value. If we want one of the wires to overcome the force, another value. But now in this one, we're expecting a smaller value if we want the fields to work together. So our new formula for this one will be, instead of subtraction, it's going to be addition. So the total is going to be equal to B1 plus B2. And then again, we'll have to solve for B2 because our sum of B and B1 both have. Is that right there, right? No, I didn't. Yeah, there we go. And again, it's going to be basically the same formulas as before, just in a different spots here. 2, 5, 2. And it's really good to get into the habit of just writing out the whole thing and then just canceling it by hand instead of trying to cancel it in your head. That's another thing I'd recommend. Just writing it out first and then crossing, like physically crossing it out on your paper and then plugging it into your calculator. Obviously, you don't want to plug in all these constants and symbols into your calculator when you can easily just be, crossed out like this. Because again, you'll accidentally cross out that 2, and then all of a sudden your answer is, not even close to what it should be. So now this formula will simplify to, not formula, this equation will simplify to this. So like I said, another way to check yourself is just understand the physics behind it. If the wires are going in opposite ways, their forces will be going in the same way. So your individual values should be less than to equal the same value as, say, 2 forces opposing each other, which would need high values for one of them to cancel with the other. I feel like I explained that poorly just now. I hope you can understand what I mean. Problem space with this, I personally don't understand E&M very well. The right-hand rule took a little bit to get used to, and this is obviously necessary to figure out. This little diagram I drew here, I didn't really explain it in depth as I probably could have, but this diagram was all right-hand rule, just using your right hand wrapped around the wire to figure out the direction of the force to then determine what values you should be expecting in your equations, whether you should be adding the forces or subtracting I keep saying forces, I feel like I should be saying field, yeah. Whether I should be adding the field or subtracting the field. So it's a lot of little things. Obviously this isn't that difficult of a problem, but again, like I say, you don't understand the small parts, like the right-hand rules, the direction of your field, then this could sort of be quite a challenging problem, but I hope this helped.